Hello everyone. Rocket technology has been advancing in leaps and bounds for the past decade, from the Perseverance rover landing on Mars to SpaceX developing reusable orbital vehicles. Space launches are happening more frequently, and in the future will probably be as often as planes taking off. The benefits of being able to launch things into space in a cost-effective manner is paramount to research, communications, and exploration. Rockets work by combining an oxidizer, usually liquid oxygen, with a fuel, most commonly hydrogen, methane, or RP2, to overcome the force of gravity. In most rockets, 85% of the mass is fuel or oxidizer. To put that into perspective, only 4% of a car's weight is fuel. Out of this comes something called the Tsiolkovsky rocket equation, better known as the tyranny of the rocket equation, which is, as the payload becomes larger, exponentially more fuel is needed to escape Earth's gravity. This makes it nearly impossible to launch much more than 150,000 kilograms of payload into space. This is simply a fact of physics that cannot be broken, though there is an idea to mitigate its effects on rockets. This idea came from British company Reaction Rockets Limited, that has built a hybrid hypersonic rocket engine that uses air in the lower atmosphere instead of oxidizer. This provides several benefits. First, the launch weight is greatly reduced, as a large portion of the liquid oxygen is not needed. This allows for the possibility to carry much larger payloads in smaller rockets, which would be a massive breakthrough in the space industry. Everything from new propulsion systems to larger research facilities like the International Space Station would become possible. Also, due to the lighter launch weight, an air-breathing rocket would allegedly allow for single-stage rockets. Traditionally, single-stage rockets have not been overly successful, though they do make for less complicated and generally easier to assemble rockets. Both of these benefits would also significantly reduce the cost per flight of such a vehicle, which would further open up space for research and businesses. Now, the engine has two modes: a low atmosphere, air-breathing mode, which it uses the air and liquid hydrogen for the combustion reaction, similar to a jet engine. After reaching Mach 5.2 and about 28 kilometers up, the air is too thin and moving too fast to create successful combustion, so the air intakes close. The engine switches stored liquid oxygen and liquid hydrogen for the remainder of the flight, allowing it to hit orbital velocities at around 29,000 kilometers per hour. Using two modes of operation allows for greater efficiency and both on-Earth and space applications. However, the revolutionary piece of technology on this engine is not the propulsion system at the back, but rather the pre-cooler at the front. The idea behind a pre-cooler is to cool the air entering the engine to protect the materials, as at Mach 5, the air can heat up to over 1,000 degrees Celsius. But more notably, it allows the air to become very compressed to feed the engine with enough oxygen to create a powerful combustion. The pre-cooler has the ability to cool the 1,000-degree air to minus 150 degrees in 10 milliseconds. This extraordinary feat is accomplished by using 50 kilometers of piping with walls thinner than a human hair containing supercooled helium to effectively drop the temperature more than 1,100 degrees. Now let's take a look at the entire workings of the engine. When air enters the engine, it is split to go through the pre-cooler or around the walls of the engine to a ramjet. If it enters the pre-cooler, it is rapidly cooled, then passes through a turbo compressor to further increase the pressure of the air. Finally, the air is mixed with hydrogen, ignited, and exhausted through 4 bell nozzles at the back. The ramjet portion of the engine is an auxiliary thrust mechanism made to burn excess hydrogen that is used to cool down the helium loop in the pre-cooler. This hybrid rocket engine has enormous potential to revolutionize the space industry, mostly due to the higher payload capacity. It would likely make launching rockets easy enough to enable goals like colonizing Mars a possibility. And who knows, this air-breathing rocket could also be the end of staged rockets. If you enjoyed this video, please support the channel by subscribing and I will see you all soon with a brand new video.